Hello class, this is Mr. McCallum again. I'm back and we're now working on page 2, and the first question here asks us to find the slope of a line containing the given points. Well, hopefully you remember from function notation that the 2 represents the x value and what the function is equal to is the y value. So this is the point 2 comma negative 12, and f of negative 19 equaling 11 is the point negative 19 comma 11. And for slope, it's the change in y's over the change in x's. So you would just have negative 12 minus 11 over over the change in y's over the change in x's, so negative 12 minus 11 over 2 minus negative 19, and that will give you negative 23 over 21, and that would be your slope, negative 23 over 21, choice B. Okay, so then on the next one it says for the function, find the maximum number of real zeros that the function can have, the maximum x-intercepts the function have, and the maximum number of turning points that the graph the function have. Well, the maximum number of real zeros is found by looking at the exponent. So for choice, so our first answer is 3, because the exponent is 3. The maximum number of x-intercepts the function can have is also 3, because the number of intercepts is also the same as the zeros, and the number of turning points that the graph can have, the maximum number, is based upon the order. The maximum number of turning points is always 1 less than the degree, so that would be 2. So choice A would be our answer for that. On the next question, find the vertical asymptote for the graph. Well, vertical asymptotes are always found in the denominator, so you need to factor x squared minus 36 and find its zeros. So that would be x plus 36, x plus 6, x minus 6. So our asymptotes, vertical asymptotes, would be found at the location of x equals negative 6 and x equals 6. So that would be choice D. Don't fall for this trap. It's saying y equals. You don't want to make that mistake, so that would be choice D. Moving along, it shows a polynomial with in factored form, and notice it's giving a question about the multiplicity. So when you look at this, you see that this one, the first part, x squared, that has a 0 at x equals 0, and the multiplicity is 2. For this one, the 0 is 9, and its multiplicity is equal to 1. And for the last one, its 0 is x equals negative 2, and its multiplicity is 3, because the power is 3. So we just got to find the right answer for that. So at negative 2 we have multiplicity 3, so that leaves us with these 3 choices. At 0 has multiplicity 2, and 9 has multiplicity 1, so the answer is choice D. So now we use synthetic division to determine which of the following, determine whether a given number is a 0. So they want to know if negative 1 is a 0. So over here I'm going to do synthetic division. Make sure that, notice it has the fourth, the second, so they skipped a term with us. So we want to make sure we write the coefficients. You remember what terms to put in. So our first term will be negative 1, because that's a coefficient negative 1. Then we'll have a 0. Then we'll have a 7, a negative 4, and a negative 10. And remember to put in front of it, you want to put the 0 they want you to check. So I have a negative 1 here, and I'm just going to make use of this space here to check to see if I get if this is truly a 0, where synthetic division will work. So negative 1 comes down. When I multiply it, I get 1. I add the terms, I get 1. 0 plus 1 is 1, multiplied by negative 1. So now that makes 6. Now this makes negative 6. When you add them together, you'll get negative 10, and when you multiply by negative 1, you get 10, leaving a remainder of 0. So yes, this is a root or a 0. Looking at end behavior, remember when you have the degree is 3, the end behavior looks like, remember we did the arm signals for what a cubic function would look like, so choice B would be our answer. And then when we move on, it says, hey, consider the discriminant, b squared minus 4ac. Remember, that's the term that's inside the quadratic formula. If this is negative, you have two imaginary solutions. If it's positive, you have two real solutions. And if it's 0, you have a double root. So let's take a look at this, and we'll just analyze what the discriminant is. So the a value is 1, the b value is 5, and the c value is 6. So b squared minus 4ac will equal 25 minus 4 times 1 times 6, so that's going to equal 1. So that means we have two real roots, and that would be choice A. Oh, I skipped 14. Look at that. Let me go back and notice it's a even order, which means it will either look like that for end behavior or that. Since the leading coefficient's negative, it'll be choice C, pointing down. Let's now jump back to number 16, and they want us to do discriminant work on that again. The a value is 1, the b value is negative 4, and the c value is 7. So my discriminant is going to tell me when I do b squared minus 4ac, I've got negative 4. Remember, you square the whole thing. Minus 4 times 1 times 7. So this will give me 16 minus 28. That will be negative. And a negative discriminant means your roots are going to be imaginary. So, well, it looks like I'm done with page 2. So hopefully this was of help to you, the explanation. Remember, any formulas that you think might be handy, like the discriminant or the quadratic formula, or even a synthetic division explanation, you can write that down on your note card. So anyway, I'm going to end this video so I can start with the next page.